Excellent. We might. All right. Oh, I forgot to ask you guys too. You guys are okay with me recording this? And by the way, guys, if you do not want your face showing up on the recording, make sure you turn off your video camera, okay? So going back to this, guys, what would be the horizontal asymptotes for this rational function right here? What's the horizontal asymptote? By the way, horizontal asymptote is on the test. Remember the horizontal, oh, sorry. Okay, Mo, come on. I'm sorry, guys. I'm talking to my dog. Mo, come over here. Go to your bed. Go to your bed. All right, thank you, bud. All right, so guys, for the horizontal asymptote, the horizontal asymptote is a line which a function approaches from both sides, from the positive side of the y-axis as well as from the negative side of the y-axis, but will never get to. So the big question is, what is the horizontal asymptote for this problem? Anybody? Nobody? Come on, guys. Okay, so let's go over this. So to find the horizontal asymptote, we're going to analyze the degree in the numerator. In this case, it's 1. The degree in the denominator, which is also 1. So since the degree in the numerator is equal to the degree in the denominator, the horizontal asymptote will be the equation y equals 2, the leading coefficient in the numerator, which is 200, over the leading coefficient in the denominator, which is 1. So when you simplify this, this becomes y equals 200. That's the horizontal asymptote. Now, recap, guys. This is a company that's manufacturing mountain bikes. Their fixed cost is $300,000, and then it costs about $200 to produce each bicycle. Now, remember, this is a horizontal asymptote at y equals to 200. So think about what that means. We're going to come back to it later on because that's the last part of the problem. All right, so now let's go back to part C, guys. Part C is this. What is the average cost of producing 500 mountain bikes, 1,000 mountain bikes, 2,000 mountain bikes? So what you do is you go ahead and go into the average cost function, which is this one right here, okay? And you're going to substitute 500 in for X, 1,000 for X, 2,000 for Y. Now, if you have a graphing calculator, you can go ahead and go into your Y editing screen and type this into your graphing calculator. I don't know who has their graphing calculator in front of them. Who has a graphing calculator? Okay. Give me a thumbs up if you've got a graphing calculator in front of you, because I certainly don't have one with me. Anybody? Okay, nobody. All right, so anyways, guys, let me go ahead and quickly show you. So to calculate the average cost of 500 bikes, you would take the 500, go into the average cost function, 300,000 plus 200x over x, and substitute the 500 in, and then divide it by 500 to calculate the average cost. Now, the reason why I asked if for the graphing calculator is, if you have a graphing calculator, you would go ahead and type in this function into the Y editing screen, and then use the table to help you figure this out, guys. Because doing this part right here on a calculator, that's time consuming. That's very, very tedious. So it's easier for you to go ahead and plug this into the calculator, okay? So let me go ahead and show you guys. Now, if we plug this into the calculator, you guys go ahead and plug it into the calculator, see what you get while I try and do it myself. All right. So 300,000 times, actually plus 200 times 500 divided by 500 gives me an average cost of 800, guys, 800. So when they manufacture 500 bikes, the average cost of each bike goes to 800 per bike, okay? So now we're gonna do it again, but this time we're gonna do it with 1,000 bikes. So we're gonna go ahead and fill in 1,000 for every single X. So this time we're gonna do C of 1,000, and then, okay, equals to 300,000 plus 200 times the 1,000 and divided by 1,000. I forgot to put my 1,000 in the denominator, so let me fix that right there. Okay, so that's 1,000 in the denominator, guys. Go ahead and fix that for me, and then plug it into your calculator. Let's see what we come up with. You guys go ahead and plug it into your calculators, please. So what is the average cost when 1,000 bikes are produced? By the way, guys, if you are on a calculator, it makes it so much easier. All you have to do once you have your function typed into the widening screen is to go ahead and look at the table to find these values. All right, now we're gonna divide this by 1,000. And guys, that drops the average cost down to $500. All right, so what do you guys notice is happening as the number of bikes produced? What's happening to the average cost? Is it increasing or is it decreasing?
It's decreasing.
It's decreasing, okay? So the question is, if the average cost keeps decreasing, what number is it trying to get to?
0
0?
or close to.
Close to 0? Now, was that David?
Yes.
Okay, now David, can we produce a mountain bike for $0? Because that's what that
Probably
means.
not.
Can we produce a mountain bike for $0? Nope, we can't. So now the question is, again, what number is the average cost trying to get to?
200.
200. Because remember, the average cost, the cost function said the overhead cost for these bikes is 300,000 plus 200 to produce each bike. But what happens is that as you increase the number of bikes that are produced, the cost goes down. And so the more bikes you produce, the less the average cost per bike. So now the question that I asked you guys was, what is the average cost trying to get to? It's trying to get to as low as possible. And what's the lowest it could get to? 200. And so the question you guys should be having in your head is, will it ever get to 200? Did somebody do the 2,000 average cost?
350.
50?
350.
350. Thank you, David. Okay. So when 2,000 bikes are produced, the average cost goes down to 350. Guys, remember, we're trying to get to 200. So if we were to keep this going, do you think we would get to the 200? Yes or no? Oh, they have 4,000 on here too, guys. So let's do the 4,000 as well. Okay. So let's go ahead and plug in that 4,000. And so at 4,000, what does the average cost go down to?
275.
275. All right, David. Okay, 275. 275 is the average cost when 4,000 bikes are produced. Okay, so average cost of 275. Guys, we keep increasing the number of bikes produced. The average cost keeps going down and getting closer and closer to what value?
200.
200. Will the average cost ever get to 200? That's the big question. Yes or no? What do you guys think? All right. Give me a thumbs up if you think it will get to 200. All right. Now, those of you with the graphing calculator, you can actually check it. All right. So you want to scroll through the table increasing the x values. By the way, guys, if you're typing this on the graphing calculator, anybody need help with typing this on the graphing calculator? No? Okay, so you guys are good. So when you graph it on the graphing calculator, you might want to go ahead and change your table setting. So your table settings, personally, I would go ahead and start, table start at 0. And then the change in the table, I would go ahead and do increments of 500. That way, your table can move a little faster. When you're scrolling through the table, it can move faster. So once again, once you have your function in there, go ahead and change your table setting, starting at 0. And then the change in the table is what's really critical. Change it to 500 so when you're navigating through the chart, you can navigate a little faster. All right, guys. So bottom line, we've got the average cost up 500, 1,000, 2,000, 4,000. As the number of bikes produced increases, the average cost decreases. At 4,000, it has decreased to 275. And no, the function will never get to, the average cost will never get to 200. So the question is, why is that? Why is it that the graph or the average cost will not reach 200? Because the average cost, guys, they're trying to get to the 200 is the horizontal asymptote. The graph, the function, the average cost gets closer and closer to it, but will never get there. Now, this is a really good business application type of question for those of you moving on to business calculus, which is one of the classes you can take immediately after this one, okay? Excellent business application question. So this average cost will never reach 200. Now, why is that, guys? Ooh, nobody's answering. Huh? Go ahead. Nobody? Oh, okay. All right. So then one last thing I need to address, and that is the horizontal asymptote. I think I've already addressed it. Now, the horizontal asymptote for this one is y equals to 200. I gave you guys that earlier, okay? And so what does the horizontal asymptote mean? Describe what this means in practical terms. Does it mean A, when 200 bicycles are produced in a month, the cost per bicycle is at a minimum? Does it mean B, the cost per bicycle approaches $200 as more bicycles are produced in a month? C, when 300,000 bicycles are produced in a month, the cost per bicycle is at a minimum? Or D, the cost per bicycle approaches 300,000 as more bicycles are produced in a month? Which one, guys? A, B, C, or D? What does the average cost, what does the y equals to 100 horizontal asymptote mean? A, B, C, or D? Anybody?
Okay. The question again?
The question was, describe what this means in practical terms. The horizontal asymptote y equals to 200. Does it mean when 200 bikes are produced in a month, that's A, the cost per bicycle is at a minimum? Does it mean B, the cost per bicycle approaches $200 as more bikes are produced in a month? Does it mean C, when 300,000 bikes are produced in a month, the cost per bicycle is at a minimum? Or does it mean D, the cost per bicycle approaches 300,000 as more bicycles are produced in a month? Which one is it, guys? No? Okay. That one, guys, is B. Obviously, I've already told you that. As more bicycles are produced, the cost approaches 200. And remember, when you type in your horizontal asymptote, it must be in the form of an equation. So you must type it in as y equals to 200. And you will see some questions like that on the test. Just a reminder, guys, the test will open up today. Okay? You'll have until Friday. It opens up at 11 a.m. this morning. You'll have until Friday to complete the test by midnight. Now, as you do the test, you will notice some full response questions on there. So you want to write down your work for the full response questions. Make sure it's well organized so that if you get some of these questions wrong, you can snap a picture of your work, email it to me so I can see if I can give you some partial credit for those full response questions. All right. Anything else, guys? No? All right. So I'm going to move on to the next lesson, which is our last lesson. And the last lesson is going to be on the rational inequalities and the polynomial inequalities. And this is going to be lesson 3.6. We're looking at polynomial and rational inequalities. All right. Now, we're going to start with the polynomial inequalities first. And yes, some of these are on the test, so pay careful attention as we go through it, guys. I will let you know which questions you're going to see on the test. For the polynomial inequalities, guys, step number 1 is to rewrite the polynomial. If necessary, rewrite the poly as the poly is greater than 0 or equal to 0, it doesn't matter, or the polynomial is less than or equal to 0. So in other words, isolate the polynomial, get the polynomial by itself. Isolate the polynomial. Now, once you have the polynomial isolated, number 2, we're going to solve the polynomial. And for the most part, guys, they are factorable. All right, so you might want to go ahead and factor the polynomial and solve. Number 3, those values that you find for the polynomial, those will become the critical values, critical or boundary values. Unlike before where we're just solving a polynomial, here we're looking for not one value or 2, 3 values. We're looking for a range of solutions. So once you solve the polynomial, guys, those values that you find will become the critical or boundary values. Now, the next step is to go ahead and plot the critical or boundary values on the number line. Next, you want to go ahead and test each region. And when you test these regions, guys, you are simply checking to see if it is positive or if it is going to be a negative, all right? And then when you test these regions, what you have to keep in mind is that the truth values alternate. And when the truth values alternate, that means that you could have something like this: true, false, true, or you could have something like this: false, true, false. So the majority of the time, most of the time, the truth values, they alternate. Now, step 5, you want to graph and write the interval solution. Write the interval solution. And guys, when you write these solutions, they must be in the form of an interval. So make sure you keep that in mind. There's 2 polynomial inequalities on the test. So pay careful attention. I am going to be going over a couple of them. All right. So I'm going to start with something very easy as an example. By the way, this is the last lesson in the chapter, guys. Last lesson. So here comes the first example. I am in quiz number 12. And I am doing problem number 2. Okay. For this one, I've got x squared plus 6x plus 5. There's a plus sign in there somewhere. Is greater than 0. Obviously, the polynomial is already isolated, so you want to solve the polynomial by factoring. What 2 numbers multiply to give you 5 and add to give you 6? That would be positive 5 and positive 1. So the factors are x plus 5, x plus 1. So now once you have your two binomial factors, you can go ahead and find those values, those critical values, solve it. What value makes x plus 5 0? -5. What value makes x plus 1 0? That would be a -1. So these two values become your critical or boundary values on the number line. There's an O in there somewhere, guys, okay? Boundary values on the number line. So we're gonna go to the number line and plot these on the number line. So you got one at -5, and then the other one is at -1. So guys, what you've done now, once you plot these values on the number line, is to separate the number line into 3 regions, okay? So you got region 1 to the left of -5, region 2 in between the -5 and the -1, and region 3, which is everything to the right of the -1. By the way, 0 is right there. Now, when you are testing these regions, okay, the best value, of course, to test with is 0. So you take the 0, go back into the original problem, plug it in, substitute it in for every single x. When you plug it in, what you end up with is 5 is greater than or equal to 0. So you ask the question, is 5 greater than or equal to 0? Yes. 5 is definitely greater than or equal to 0. So that makes region number 3 true. Now, remember I told you guys in the steps that the truth values, they're alternating. So if region 3 is true, that would make, or you would assume region 2 is false, and you would assume region 1 is true. But if you're not sure, guys, go plug in some values. Like in region 2, I'm gonna plug in -2. If I plug in -2 into the original problem, and I work it out, that's a -2 right there, plus 5 is going to equal to 0. So I get +4 minus 12 plus 5 greater than or equal to 0. And so 4 minus 12 is -8. -8 plus 5 gives me -3. Is -3 greater than or equal to 0? Nope, that's absolutely false. So by doing this, it verifies the fact that this region right here is false. And yes, that would make this region right here true. And if you're still not sure, go ahead and plug in a value like -10 or something, work it out, and it should be true. It should make the original inequality true. Now, since the true regions are region 1 and region 3, we're going to now shade these two regions in, indicating where you will find all the solutions that will make the original inequality true. So this would represent the graph. And now you have to express this in interval notation. So in interval notation, remember in numerical order, the graph would go from -infinity. The solution set would go from -infinity up to -5. And then close the bracket. By the way, guys, the reason we're using a bracket is because of the inequality symbol, okay? So because it's greater than or equal to, we want to include the boundary values. And if you're not sure, you can always plug in those values and see if it makes the polynomial true. And then we've got another region where we have a set of solutions from -1 up to +infinity. So we're using the union sign to show that it's a union of these two intervals, guys. So that's the solution for this particular problem. Now on the test, they will ask you for both the graph and the interval notation. So you have to be ready to do that. Questions on this one, guys? Now, I am going to do a second example. Hold on a second. Let me see. I'm not on that screen. Let me go ahead and double check and see if you guys have any questions. No questions, guys?
Are they all going to be like this easy on the test, or?
Absolutely not. I'm about to do one that's a little bit more challenging. All right, so here comes the next one, guys. So for the next one, I've got, this is problem number 3 in the same quiz. It is 4x squared plus 23x minus 6 is less than or equal to 0. All right, now obviously this particular polynomial is a bit harder to factor than the first one we just did. Now, how do we determine if it's factorable? Do a quick AC to see if it works. You know, the AC method. So we take A, which is 4. We multiply it by -6, which is C. So we get -24. So the question is, can we find two numbers that multiply to give us -24 and add to give us +23? Absolutely. That would be 24 times -1. 24 times -1 is -24. 24 minus 1 gives you +23. So it works. So we can factor this one. Now, if you guys want to do the AC method, go ahead. But I'm just going to go ahead and guess and check this one. The 4x squared, I'm splitting it up into 4x times x. And then the -6, guys, I am going to split it up to -1, +6. Now, why did I split it up like that? Because I want to make sure to multiply the 4x and the 6 so I could get my 24x. And I want to make sure I can multiply these two together so I get -1x. And of course, when I add them together, I get my 23x. So there you go. There's your factors. So now you're going to take each factor, set it equal to 0, and solve so you can find your critical values. Now, when you solve this one right here, you get a -6. And then this one right here, when you solve it, what would you get, guys? 4x minus 1 equals to 0. What would the value be for x? Anybody?
1/4.
1/4. Very good, Ella. Okay, so guys, there's your two critical values. So now it's time to go on the number line, plot them on the number line. You got a -6, then you got a 1/4. 1/4 is about right there. Okay, so by plotting these critical values on the number line has been divided into, there we go, 3 regions. Okay, so you got region 1, region 2, region 3. And of course, the best number to test with is 0. Start with the 0. The only time you cannot test with the 0, guys, is if the 0 is actually one of the critical values. So if it's one of the answers, don't check with the 0. But if it's not, you can always check with 0. And 0 is the best value to test with. So we're going to take the 0, go back into the original problem, plug it in. When we substitute 0 in, we're left with -6 is less than or equal to 0. Is -6 less than or equal to 0? Absolutely true, okay? So since the truth values are alternating most of the time, if this region is true, then that would make region 3 false and region 1 true. False, false, okay? So region 1 is false, region 2 is true, region 3 is false. Now, again, if you're not sure, guys, what you do is test another value. I'm going to go to region 3. Plug in 1 into the original problem for every x. 4 times 1 plus 23 times 1 minus 6. Okay, that's going to give me 21 is less than or equal to 0. Is 21 less than or equal to 0? Absolutely not. So this would give me a false statement. So yes, we verified that region 3 is indeed false. Okay, so now since region 2 is the only true region, this is where you would go to find all the values that would make the original problem true. By the way, guys, the question on the test is very similar to this one right here, okay? So there's your graph, and now you have to express this in interval notation. So in interval notation, it would be bracket, -6, comma, 1/4, and then close off the bracket. Remember, when you write your interval notation, guys, they must be written in numerical order from left to right. All right, that's on the test, guys. One of the polynomial inequalities on the test. Any questions? No? Okay, everybody, so let me go ahead and do another one that is going to appear on the test. Let me first find it for you. Let's see here. Not this one, not that one, not this one. It's a 3rd-degree polynomial. Okay, I found it. It's number 7, guys. Okay, so number 7 is what I'm going to. Now, for problem number 7, guys, it's a third degree polynomial inequality. Third degree polynomial inequality. And it is x cubed plus 3x squared minus x minus 3. Ooh. All right, this is why my iPad has that crack on it. All right, there we go. Minus 3 is greater than or equal to 0. All right. Now, guys, this is a 4-term polynomial. How do we factor a 4-term polynomial? How do we factor a 4-term polynomial, everybody? Anybody? Come on now, guys.
Isn't it like grouping or something?
Yes, you're going to factor by grouping. There's a lot of factoring in this chapter, by the way. So we're going to go ahead and factor it by grouping. Group the first 2 terms, group the last 2 terms. All right. There's a parentheses right here, okay? So in the first group, there's a GCF of x squared. We factor it out. And that leaves us with x plus 3. In the second group, there's a -1 factor. So we're going to factor it out. That leaves us with x plus 3. So now, when we factor out the parentheses, that leaves us with x squared minus 1. Is this completely factored, guys? And the answer to that would be no, because you have that x squared minus 1. So you want to factor it further, x minus 1, x plus 1, okay? So now you can find the values that would make this polynomial 0. What value of x makes this first parenthesis 0? -3. For the second one, it would be +1. And the third one would be -1. Okay, so those 3 boundary values or critical values. So one of them is at -3, another one is at -1, another one is at +1. So by plotting these on the number line, guys, you've essentially divided up this number line into 4 regions, okay? Region 1, 2, 3, and then 4. Your job is to figure out which region or regions contains all the values that will make the original polynomial true. And obviously, the best number to test with is 0. So we're going to take the 0, go back to the original problem, plug it in for every single x, substitute. So you end up with a -3 is greater than or equal to 0. Is -3 greater than or equal to 0? Nope, that's false. So since this region is false and the truth values are alternating most of the time, that would make region 2 true, region 1 false, and then region 4, that one would be true, okay? So this means that you have a set of solutions in between -1 and -3. And remember, we're using brackets here because of the inequality symbol. So now I'm graphing to show the regions that contains all the solutions to this polynomial inequality, okay? So there's your graph. And then now the last step is to express this in interval notation. So in interval notation, you'd have a bracket, -3, comma, -1, close off the bracket, union, +1 with a bracket, all the way up to +infinity. So there's your solution set. Guys, this one is on the test, all right? Any questions? And once again, guys, the test has some multiple choice questions and some for response questions. Nothing?
How do you know what to put for the interval notation?
How do you know what to put for the interval notation? Basically, once you have the graph, okay, the graph is indicating where the solutions are for this inequality. So you're just expressing the graph in interval notation. So the first interval where you will find solutions that will make the original problem true is in this interval right here, okay? From -3 up to -1. So we write that in interval notation with a bracket, -3, comma, -1 bracket. And so here, you essentially just taking the information off the number line, lifting it off the number line, and writing it without the number line. That's all you're doing. And then the other interval occurs right there. So what do? It starts from +1 up to +1. You just write it without the number line. Bracket 1, comma, +infinity. So personally, here's a good tip for you guys. I would go ahead and graph these first, and then use the graph as a guide to help me write my interval notation. All right, guys. So here's the last part of this, and that is the rational inequalities, okay? By the way, that last question, I've already said that, but I'll say it again. That last question that we just did is on the test, everybody. All right, rational inequalities. Now, guys, if after I'm done with this session, you feel like you have some additional questions, I'll stay with you so you can ask your questions, okay? So the rational inequalities, they work very similar to the polynomial inequalities. So of course, the first step is to isolate the rational let me see here, expression, or just get it by itself. Rewrite it so that it looks like this, guys. You have your rational function greater than or equal to 0, or your rational function is less than or equal to 0. So rewrite it like that, okay? Now, once you have it written like that, the next step is to, and this is critical here, because you're dealing with rational functions, and these rational functions, they have variables in the denominator. So you have to be on the lookout for the restricted, find those restrictions, restricted or excluded values. What are those values that will make the rational function or rational inequality here undefined? So here's an example, guys. Here's one. Okay, what value is restricted or excluded from the domain of this function right here? What's the value? What can x equal to?
1 or 3.
Ooh.
No.
Now, guys, remember the restricted value is that number that makes what part of it 0? Which part? The denominator. So the restricted value right here would be 3. Now, the next step, number 3, we're going to solve the rational inequality. Now, to solve it, guys, because this one right here is just equal to 0, sometimes you can just take the numerator and set it equal to 0. Now, if this one right here is not equal to 0, you have to make sure you isolate it so it is equal to 0. Now, next, we're going to take that x minus 1, set it equal to 0, because that's the numerator, and solve it. So we get x equals to 1. By the way, guys, this is a critical value, and this also becomes a critical value. So now that we solve it, the next step, of course, is to graph, test each region, and then write the interval solution, okay? Test each region and write the interval solution, just like with the polynomial inequalities. So we're gonna go to the number line once again. Now, since we're dealing with a whole bunch of fractions here, be careful, okay? So we got one solution at +1. We got another one at +3. So this divides the number line into 3 regions, okay? So I'm breaking it up so you can see the 3 regions, region 1, region 2, region 3, and there we go. Now 0 is way over here, and of course, we're going to test with 0 first. If we take 0, we plug it back into the original problem, we're going to get a +1/3 is greater than 0. Is +1/3 greater than 0? Absolutely true. Absolutely. Okay. Now, let's do it in region 2. Let's pick a value there. If we take 2, we plug it in for each x. We get 2 minus 1 over 2 minus 3, which gives us a negative 1 over, a positive 1 over negative 1, which is actually negative 1. So the question is negative 1 greater than 0, guys? Nope, that's false, okay? Now, since the truth values are alternating and region 1 was true, region 2 is false, that would mean region 3 is true. But just to be on the safe side, we can go ahead and test it out. And so we just pick a value, choose a value in region 3. It doesn't matter what it is. You can choose a number like 4, okay? And plug it back into the original problem. What do we get? When we do 4 minus 1, we get 3. 4 minus 3, that gives us 1. So the answer turns out to be 3 over here. And so the question is 3 greater or equal to, greater than 0? Absolutely. 3 is greater than 0, so that makes this region true as well. Okay, I just erased a lot of that, guys. So let me fix that for you guys. Okay, so this region is true. This region right here is also true. So the solution set for this one will be from negative infinity up to 1, but 1 is excluded. And then you got another set of solution from 3, not included, all the way up to positive infinity. Now, once you have this, you got to express it in interval notation. So the interval notation would be negative infinity up to 1, close the parentheses, union, positive 3 up to positive infinity. And there you go. Now, this is an easy problem, guys. In comparison to the other ones that you're going to see, this one is very straightforward. Find the restricted value. That becomes a critical value on the number line. Find the solution to the rational inequality, okay? And if it is greater than or equal to 0, less than or equal to 0, or something like that, you can take the numerator, set it equal to 0 and solve, which was the positive 1. And that's another critical value. Plot those critical values on the number line, text the regions, graph it, and then write your interval solution, okay? This one is very, very straightforward. All right, so now let me show you the ones that you're going to go ahead and see on the test. And guys, again, be very careful with the test. Before you submit it, double check your answers. Now, what I've noticed is that the algorithms in my math lab, they're consistently changing now. What I notice is that when you're going through a test, people, on my math lab, is that if you view a question, you don't answer it, and you move on, when you come back to that problem will change. So be careful with that, okay? Now, here's a question, one of 2 rational inequalities that will be on the test, guys. And this one right here is negative x plus 9 over x minus 2 is greater than or equal to 0. All right, so on this one right here, we got to find the restricted value on this one. What's the value that makes the denominator 0, guys? What do you think? Anybody?
2.
2. Very good. Okay. Now, we got to solve this. So to solve it, we're going to take the numerator, negative x plus 9, set it equal to 0, and solve. Now, before I move on, let me address something else, guys. Okay, right here, the inequality symbol is greater than or equal to. Remember, when you're writing your interval, when you're graphing, you have to either include or exclude the boundary value. Can we use a bracket with the positive 2? That's the question I wanted to ask you guys. Can we use a bracket with the positive 2 when we graph it or write the interval notation for it? Yes or no? What do you guys think?
No.
No. Very good, David. Because, guys, you cannot use a bracket, what I would do is put parentheses next to x equals to 2 so that I know when I'm writing the interval notation, when I'm graphing it, I gotta use parentheses. You cannot use the bracket, because if you use the bracket, you're saying it's okay for 2 to be a part of the domain of this function right here, and 2 can't be a part of the domain because it makes the denominator 0. So remember that. That's really crucial, guys. All right. So now I am going to plot my 2 values on the number line, one of which is at 2, the other one is at 9. So that divides the number line into 3 regions. So now I'm going to test each region. My 0 is over here, so obviously I'm going to test with 0 first. If I take 0 and I go back into the original problem, plug it in for each x, what I'm left with is -9 over 2. That's a negative value. A negative value cannot be greater than 0. So this region is false. So since the truth values are alternating most of the time, that would make this region true. And that would make this region right here false. Okay, but if you're not sure, test it out with something else, like 5 or something. Okay, if I plug in 5 into the original problem, -5 plus 9 is 4. 5 minus 2 is 3. So the question is 4/3 greater or equal to 0? Absolutely. And you could also do a value over here. -10 plus 9 is -1. 10 minus 2 gives you 8. Is -1 8 greater than or equal to 0? That's absolutely false. All right, guys. So once again, the true region is between 2 and 9. And since it's between 2 and 9 right here, okay, we have to go ahead and graph it. Now, to graph this one, remember, guys, you cannot use a bracket at 2. We're going to use a parenthesis so we can exclude it. And then the +9 can be included. So we're going to go ahead and shade all of this in to reflect all the values that would make the original rational inequality true. So this is the interval where you would find those values, all those values that will make the problem true. So now we express it in interval notation. So in interval notation will be parentheses 2, comma, 9, close off the bracket. All right, guys, this one is on the test. Now, the question you should be asking yourself is, if I see this one on the test, am I gonna be okay with it? Am I going to be okay with it? Now, if you're not going to be okay with it, you should ask a question, all right? Now, guys, remember after this test, we have one more test left, and that last test is going to be on the logarithms and the exponential functions. I always like to do 4 tests and drop the lowest one, so there's one more test coming up, okay? The 4th test will be on chapter 4. All right, so are you guys gonna be okay with this one on the test? Give me a thumbs up if you're going to be okay. All right, Ashley. Lily says yes. Okay. Elizabeth Duran says yes. Megan says yes. Oh, Megan, you changed the color of your thumbs up. How'd you do that? I didn't know you could change the color. That's interesting. Oh, wow. Okay. Anyways, guys, here comes the last question I'm going to do with you today. Now, remember, if you want to stay after to ask me some questions, you're welcome to stay after. I'll remain in the chat. Okay, now this one, guys, you have to be extremely careful with it, okay? This may be a little long-winded, but let me start off by saying this particular example right here is similar to one of the questions you're going to see on the test. Now, for this particular problem, you will notice, unlike the previous 2 we did, there's a 2 over here, okay? So that is going to affect this problem. Now, first, we can go ahead and find the restricted value, guys. What's the restricted value? What value makes the denominator 0 on this one? Anybody? Come on, guys. Nobody?
It's -2.
-2. Very good. Okay, -2 is the value that makes the denominator 0. All right. So now, because you have this 2 over here, you first have to isolate this rational expression or the rational inequality. So how do we isolate it? We want to rewrite it so that everything is on the left side and you have a 0 on the right side. In other words, I will show you a shortcut after I'm done with this, okay? You move the 2 over, so you get x minus 3 over x plus 2. Minus 2 is less than or equal to 0. Now, we're not done. You have to take the left side and rewrite it as a single fraction, as in find the least common denominator and then change the numerators accordingly so you can rewrite it as a single fraction. So the denominator of the -2 is 1, okay? The least common denominator between these two fractions would be x plus 2. So when we rewrite this, we'd rewrite it as x minus 3 over x plus 2 minus 2 times x plus 2. There's a 2 right there. Over x plus 2. Now, I am going to simplify this. So I get x minus 3 minus 2x minus 2. No, minus 4. That's a minus 4 here, guys. All right. Let me fix that. Okay. Minus 4 over x plus 2. Now, combine like terms. And so when you combine your like terms, what you end up with is, let me go ahead and use a different color here. Okay. You combine the x with -2x, so it's going to give you a -x. Combine the -3 with the -4, so that's going to give you a -7. And all of this is over x plus 2. And of course, that will be less than or equal to 0. So what I just did was to rewrite the problem so I have my rational function isolated and it's less than or equal to 0. Now, once I have it in this form, then I'm going to solve it just like I did the previous problem. I already have my restricted value right there. So now I'm going to solve it by taking the numerator, -x minus 7, set it equal to 0, and solve. So it looks like -7 will be the value of x. So there's my other critical value, guys. So I got two critical values. X cannot equal to -2. X equals to -2, x equals to -7. Now, I'm sure some of you were confused by all this work I just did over here, guys. All that work right there to get the rational inequalities to look like this. That was a bit confusing, okay? So here's an optional way for you to solve and get the value of x, okay? So let me erase some of this and I'll go ahead and show it to you guys. And once again, guys, this question is on the test. It's on the assignment, okay? So here's how you do it. Here's a quick way to do it. And some of you will really like this. The textbook doesn't recommend this, but it works, okay? So you take x minus 3, x plus 2 over x plus 2, set it equal to 2, and then cross multiply it. This is basically a proportion, so cross multiply. So you get x minus 3 is equal to 2 times x plus 2. And so x minus 3 will equal to 2x plus 4. And so 2x plus 4, I'm going to subtract x from both sides. So I get -3 is equal to x plus 4. Okay. And then subtract the 4 from both sides. And let me see here. That's a -3 right there, guys. Subtract the 4 from both sides to get x equals to -7. Okay. I ran out of room at the bottom. So x is also equal to -7. So guys, as you can tell, we get the exact same answer, the same critical value of -7. So does it really make that much of a difference? No, it doesn't. So answer this question for me. Which method do you guys like? The first one or the second one? What do you think? Which one do you prefer? The first one or the second?
Second one.
The second one, David said. Okay. First or second? All right.
Second.
I think the second one is more straightforward. So most students would prefer to do it the second way, okay? But of course, there's a right way to do it. All right, guys. Now, next, I am going to go to the number line, plot those critical values on the number line. So I've got one at -7. The other one is at -2. And of course, there's my 0. So the number line has been broken up into 3 regions. So now my job is to test each region to find which region or regions contains all the values that would make the original problem true. So I'm going to take the 0, of course, and plug it back into the original problem right there to see what happens. What's the outcome? So when I plug in 0, I end up with a -3/2. Obviously, a negative is always going to be less than a positive, guys. So this region is true. Now, if we follow through with the fact that the truth values are alternating, that would make the middle region false, and that would make the region to the left true. But of course, if you're not sure, and sometimes even when you are sure, go back in and plug in these values, okay? So I'm going to grab -5 in this region right here. So if I grab -5 in this region, I go into the original problem and I plug it in. I am going to get a -8 over a -3, which would result in a +8/3 is a positive 8/3, which is 2.67 going to be less than 2, guys? Absolutely not. That's completely false, okay? So this is verifying the fact that region 2 in the middle is false, okay? You can do it for the left region too, you don't have to. So obviously, our solution set, guys, is going to be from -∞ up to -7. Should we include the 7? Should we use a bracket or parentheses on the -7? Bracket or parentheses? What do you guys think? Bracket or parentheses? Which one, guys? So this one right here is going to be a bracket. Now, why are we using a bracket? Because of the inequality symbol. Now, what about the -2? Should we use a bracket or should we use a parentheses, guys?
Parentheses.
Parentheses. You cannot include the -2. You're going to use a parentheses with the -2. All right. So there you go. There's your graph. So now you must express this in interval notation. So in interval notation, guys, it would be from -∞ up to -7, which is included with a bracket. And then, all right, union from, that's a parentheses right here, guys. Parentheses. If my, okay, this is not writing. My stylus is not working with me. Sometimes it gets very finicky. Okay, union, parentheses, -2 up to +∞. Here, let me erase this mess over here. All right, guys. There we go. So that was the last question. Any issues, guys? Any questions? Nothing? All right, any questions for me? Nothing? Okay, so I am going to go ahead and end class.